Hello everyone, this is our Aesthetic Computing Project 3 for Spring 2010. This video gives you a demo for the game V equals to IR, which is based on the Ohm's law. The aim of the project was to aesthetically represent a mathematical formula. We have chosen the most fundamental law of electronics, that is Ohm's law, V equals to IR, where V is the potential difference or voltage, I is the current flowing in the circuit, and R is the resistance applied. Now in our game, the water flow basically represents the current flowing in the circuit. As the water hits the turbine, the speed with which the turbine moves depends upon the volume of the water hitting it, and the rotation of the turbine makes the bulb light up. In our game, the player has to basically move the slab up and down using up and down arrow key, and the slab acts as a resistance which controls the flow of water, which in turn controls the speed of turbine. So the main objective of the game is to light the bulb. The bulb light up at a particular speed of turbine. So come on, let's check the information for the game. The game is based on the principle of Ohm's law, that is voltage or potential of a circuit is directly proportional to the value of current flowing in the circuit. In our project, as I have told you earlier, the water flowing internal is current, slab to control water flow is resistance, and Ohm's law states V equals to IR. So let's check the help button. The instructions for the game are as follows. The game is based on the principle Ohm's law. Aim of the game is to light the bulb by varying the water flow in the tunnel, and you can use up or down key to vary the resistance. Come on, let's play the game now. This is stage 1 for the project. Our aim is to light the bulb in the circuit. Here you can see that this is the resistance slab, this is the turbine which moves when water hits it, and this is the bulb in the circuit that is to be light up. This formula V equals to IR is the Ohm's law. As we can see here, when we move the resistance upwards, the value of the resistance decreases, and thus the volume of water flowing will increase, thereby increasing the speed of the turbine and thus increasing the value of current. So in this case, at this point of time, as we can see that the speed of turbine will not be enough to light the bulb. So when we move the resistance slab to the maximum position, keeping the resistance minimum, let's see what happens. The speed of the turbine is enough to light the bulb. This shows that the circuit needed minimum resistance for the bulb to light up in this stage. As the bulb lights up, your score becomes 50 and a button appears called next stage, which will guide you to the next stage. On playing the game, you will see that the bulb will light up by keeping the maximum resistance, that is 100. Well, this is the window that appears after you finish the game. We have used a software Game Maker to make our game V equals to IR. All the major objects and instances are placed in a room, as you can see here. In this room we are working on a 16 by 16 grid, and in this room we have placed the objects which have certain events. The objects are made of sprites, which are small static images, as you can see here. Now the objects can also have animation events or certain actions, such as to disappear on a collision. As you can see here that for the object OT initial, we have an event collision with A1, which on execution will change the instance OT initial to OT SP1, which is a moving sprite. It makes the effect when water collides with the turbine and the turbine starts moving. We have created several rooms for different stages in our game. Now, the target users for our project are people from non-science background who find it difficult to understand the most important law of electronics, that is Ohm's law. Usually the students from junior or mid-school, that is 6th to 10th grade students, always gets confused with the relation between resistance and current. The game would attract these students to play it, and in turn they would understand how increase in resistance leads to decrease in current, or decrease in resistance leads to increase in current with the voltage constant in the circuit. Thank you.